Okay, so just picking up where we left off yesterday. Yesterday we finished with example 3, so we just got a couple more things to talk about here and then one more example. So inverses of functions theorem there on page 202. So given any two functions f and g are inverse functions if and only if. So if we do it one way, like the fog way, it equals x, and then for all x in the domain. And then if we do it the other way, the Goff way, and it also equals x for all in the domain, that means that those are inverses of each other. So if you need to prove that two equations are inverses, basically you do like one version the fog way, one version the Goff way with the composites. If they both equal x, they're inverses. And then that also kind of goes along with that identity function there, because the identity function is equal to x. So it says a function that maps each element in its domain onto itself. So basically if you graph something or whatever, and then it goes back to itself, then that's also the identity function. I of x is equal to x for all x, so that's kind of the similar concept of it equaling that x. And then another thing, if they ask you something about like the domain and range of this, if you know the domain of the original stuff and the range of the original stuff, you can use that to find the domain and range of the inverse, because with the inverse, we're basically just switching the x and y around. So wouldn't that also just switch the domain and range around? It should. So like whatever the domain of your original one is, that should be the domain of or it should be the range of the inverse one. They just switch places with each other. Okay, so let's hammer out that last example then. We're gonna do quite a bit of writing here. So like this is how much writing I had on my sheet. So it's gonna be quite a bit. So I would write fairly small because it's quite a bit of solving out, putting these fractions inside other fractions. So I would write fairly small when you're doing this out here. Okay, so what they give us is it says we're supposed to use that inverse of functions theorem to determine whether f and g, and then we've got those formulas there, f of x equals whatever, g of x equals whatever, are inverses of each other. And to prove that or show that using that theorem there, basically we have to do one that's fog and one that's Goff, and see if both of those kick out x as their answer. If they both reduce all the way down to x, then they're inverses of each other. Okay, so what I would do here, like I said, I'm going to write fairly small. I'm just going to start off with the fog one. So if I do like f and then that composite g, or you could do it with parentheses as well, of our x, so this is like our fog one. What we would be doing is we'd be taking that g function and putting it inside of that f of x function. So we're going to take this fraction here and put it into both of those x spots. Okay, so like for this, it would be equal to 3, and then like I said, instead of that x, we're putting that g function in there, so it would be 3 times 5x minus 1 over x plus 3, and then following that 3x, it would just be plus 1 over, and then we've got 5 minus, and then again, instead of the x, we have to plug in that g function for it. So I'm going to go parentheses, and then the 5x minus 1 over x plus 3. Okay, so that's our setup. Now the pain in the ass with this is they're both fractions, so we got to do a bunch of solving to get all that stuff kind of combined together. Okay, so what I would do here next is I would think, okay, well, if I do like distributive property on this, that would be like a 3 over 1, right? So I'm going to take my 3 times all the stuff that's on the top of that fraction. So that would be like 15x minus 3 still over x plus 3 on the bottom, because the bottom of that fraction was just a 1. Plus, and then here when we go to do like our 1 here, can I add 1 and something with an x plus 3 on the bottom? Like, can I add two things that don't have the same bottoms for fractions? You can't. So what you actually have to do is you have to get that 1 to have the same exact bottom as this here. And to do that, I'm going to just do this in a different color so it kind of emphasizes it. You're going to take whatever your number is here times what that thing is on the bottom. Because then if we take that number times that right there, x plus 3 over x plus 3 is the same as 1, so it doesn't change that value at all, but it manipulates it in the favor of us having x plus 3 on the bottom then. And it would just be like our x over 1 there when we do that. And then same thing is going to happen on the bottom here. So first thing I would do is I would kind of think about this as like a negative here and distribute it through. So it's kind of like if it was plus like a -1 there. And again, you just do it to the top because it would be like a fraction times a fraction. So that negative is going to go to both of those things when we distribute. So it would be like 5. And then again, we're not going to be able to add those fractions together unless we have bottoms the same. So I'm going to, again, overemphasize it in a different color here. Make that x plus 3 over x plus 3, because then that'll get my bottoms the same. Plus, and then like I said here, we got to distribute that negative to all the stuff on the top. So that would make it a negative 5x, and then the negative to the negative would make it a positive 1 over our x plus 3. Put that over 1 as well with the 5. And the reason we have to do that stuff is because we don't have bottoms the same, so we can't add things together unless the bottoms are identical to each other. So now what I would do is I would do my distributing out here. So like the 1 times all that stuff, well, we know 1 times that fraction is just going to keep it as that fraction. So it would be like, do it as 2 steps here. It would be like our first fraction being exactly the same. And our other one, since it's a 1 there, is also going to be exactly the same. X plus 3 over x plus 3. And now that they have the same bottom, that's when you can then go and add those. Okay. And then I'm going to do the same thing on the bottom here, but when I distribute the 5, that is actually going to change my values around a little bit, because it'll be my 5 times my x, which would be 5x, and then 5 times the 3 would be 15. Over our bottom is just x plus 3, and then that second fraction is just going to stay exactly the same, so plus a negative 5x plus 1 over x plus 3. I'm kind of running out of room there, so I'm just going to go underneath it here. So then from there, since bottoms are the same, we can put it all as 1. So over x plus 3. And then here, if we combine this stuff together, if we put like the 15x plus the x together, that would give us 16x. And then the negative 3 and the positive 3 would actually cancel each other out, so the top would just be 16x there. Over, and then the bottom, again, both of them are out of, should have left myself more room there. Both of them are out of x plus 3. So the bottom is just x plus 3. And then there again, you're going to combine your stuff that can go together. So if I put the 5x and the negative 5x together, those cancel each other out. And then if I do the 15 plus the 1, I get 16. And then from there, what happens, since these are both out of the same value there, those kind of cancel each other out. And you're just left with 16x over 16. And then you got a 16 on the top, 16 on the bottom. Those cancel out, and you're just left with x, which was what our goal was to get to, is reducing that all down to x. And I know that that's a pain in the butt to get all the way down to that, but that's how you would prove that that works, okay? The even more pain in the butt thing is we also have to prove that for the Goff one, okay? Because it only works if they both get down to x. If only one does, then they're not inverses. They both have to get down to x. Now we have to do the same thing with the Goff one. So I'm going to draw a line here just so we can kind of tell, because my work kind of got messy here. Just that all that's with part A. And now we got to do, well, I guess all of that's with part A. I'm just going to do the Goff one, I guess, under the line. So now I switch it around, just put the G first and the F second. Now you're going to do the whole same process out with that, okay? So same thing. Got to take that f of x function, put it inside the g of x function. So it's going to be 5, and then instead of the x, we're going to take that fraction and put it in there. So 5 parentheses 3x plus 1 over 5 minus x. And then to finish off that top part, minus 1 over, and then, which one are we on? We're on this one. Then it would be our x value, so that f of x going in there. So that same fraction, 3x plus 1 over 5 minus x, but this time plus 3. That's our original setup. Then we do the same as what we did before. So like here with the 5, again, it's like 5 over 1. And we would distribute to that to the stuff on the top. So that would make that 15x plus 5 over 5 minus x. And then again, we're going to have the same issue here with those just being regular numbers and not the fraction with the same bottom. So you've got to take those numbers times that fraction bottom there, or what's on the bottom of that fraction. So it would be like, I'm going to change it to, I think, plus a negative 1 instead of minus there, so just so I remember that that's the negative goes with it, times, and again, I'm doing this bottom here. Actually, that's what I was doing in that other color. So if you want to overemphasize it in that other color, our bottom we're multiplying here is the 5 minus x over 5 minus x, and again, we can do that because something over itself is 1, so we're not changing the value at all, we're just manipulating it in our favor. And then I'm going to set up my bottom the same way. So it would be, that first one's good, we don't have to distribute or anything, so it'd just be 3x plus 1 over 5 minus x plus, and then again, we have to take our 3 times the bottom stuff there. So again, I'll do that in a different color just to kind of overemphasize what we're doing there. Okay, and of course I'm running out of room here again. I'm just going to take it over here so I can just do my work over here. Okay, so now I'm going to start kind of simplifying this out. So again, that first fraction is just going to stay the same there. So 15x plus 5 over 5 minus x plus, and then I've got to do my distributive property here. So the negative 1 times the 5, negative 1 times the negative x, so that would make it a negative 5 and a positive x, so plus x, over, and then the bottom again has got to be the 5 minus x, because they got to be the same for us to add them. Okay, top of our fraction. Bottom of our fraction, again, this first fraction is going to stay the same. So 3x plus 1 over 5 minus x plus, and then on that bottom fraction, again, we got to distribute that 3 all the way through to the top stuff. So that would make that top 15 minus 3x over, and then a bottom again, 5 minus x. And then from there, I'm just going to combine all my stuff into one fraction then, without that plus sign in the middle. So bottom is going to be 5 minus x on each. Top there, I would combine the 15x and the x to make 16x. I would combine the 5 and the negative 5. Well, that will cancel out to be a 0, so just 16x. And then our bottom fraction, again, still 5 minus x for the bottom. I would combine my x's, so 3x minus 3x, those would cancel. So I'd be left with the 15 plus the 1, which would be 16. So very similar to our one before, because now if those are both out of the same bottoms, those can go away completely. And we'll have 16x over 16 again. And then the 16s can go away. And we also get that one down all the way to x. Now we're done with that one. So what they were proving there, and not all of them are this hard. This one's just so hard because they're both fractions. If just one of them was fractions, it would be so much easier. Or if there was no fractions, it'd be so much easier. Because they're both fractions with like crazy stuff on the bottom, that's what makes it so difficult. They're not all like that, okay? But the whole purpose of that was to prove that both the fog and the goff, so like fog was equal to the goff, and they were both equal to x. So that was the whole point of that, was to show that both of them are equal to each other, and they both kick out an x for that. If they don't both kick out an x, then they're not inverses of each other, okay? And then part B of that, they just want us to verify that with a graph. So you would just type in those two original fractions there into your calculator. So you would just do like x plus 3, or 3x, sorry, 3x plus 1 divided by 5 minus x. Do you want me to put it up there? Sorry. I'm just typing these in, is all I'm doing. So just typing in the f of x into the first one, and then the g of x into the second one. 5x minus 1 divided by x plus 3. So just f of x and g of x in there. And then when you graph it, of course, I got it in the wrong form again. Z standard. So looking at those, what we look at when it's a graph is we look at if they're reflections of each other over the y equals x line. So if I had that line going through there, would those flip over and be each other? They should be. And again, it looks kind of skewed because this is a rectangular screen. If you want it to look more like a squared screen, if you go to zoom and then z square, that'll make it look more like it's a square screen, and it'll make it look more like it's actually a reflection over. So see how that kind of looks a little bit better? It's still a little bit kind of weird on the graph, but yeah, it should be reflections over that. Okay? Okay. Oh, and we got to write that, I guess, for part B. So you could just say the graphs appear to be reflection images of each other over the y equals x line. So that's kind of the other way of determining it, is flipping over that line. Okay, but to actually prove it, you got to do that whole process out. But like I said, they're not all that crazy. That one was just that crazy. Okay. All right. So that's it. Book page there, 203, 2 to 17. Skip 15 and 16b though. So skip those guys. We'll go over questions and stuff on that on Tuesday.